what really happens to your body, mind, and energy the second you die. You are going to die. I don't say this to be cruel. I say it because it is the most certain fact in your life, more certain than anything you have ever been told in a classroom, more certain than any law of physics I have ever written on a blackboard. The date is unknown, the cause is unknown, but the event itself is not in question. Not for you, not for me, not for anyone. And here is what I find extraordinary. Most people have spent their entire lives not knowing what actually happens when it occurs. Not in a religious sense. I am not talking about heaven or hell or the soul's journey. I am talking about physics, chemistry, biology, the precise, measurable, observable sequence of events that happens to the matter and energy that currently constitutes you in the seconds, minutes, hours, and years after the moment your heart stops. What happens to your body is astonishing. What happens to your mind, to the electrical and chemical processes that produce consciousness, is one of the deepest unsolved problems in all of science. And what happens to your energy is, in the most literal and precise sense, governed by the same conservation laws that govern every other process in the universe. You do not simply stop, you transform. The atoms in you have been here for billions of years, they will be here for billions more. What you are right now, alive and reading this, is a temporary, extraordinarily improbable arrangement of matter that the universe assembled once and will never assemble again in quite the same way. In the next hour, I am going to show you exactly what happens to that arrangement, second by second, atom by atom, from the first moment to the last. And I promise you, the truth is stranger than anything you have been told. The body A, second by second cascade of failing systems. Let me start with the body. Not because the body is the most important part of what you are, that question is genuinely unresolved, and I will come to it, but because the body is the most precisely understood. We know, with extraordinary detail and precision, what happens to a human body at death. And the story it tells is one of the most remarkable demonstrations of thermodynamics in action that I know of. The moment death occurs, and I will define death carefully, because the definition matters enormously for everything that follows. The first thing that happens is the cessation of active biological maintenance. Your body, right now, is an extraordinarily active system. Every second, approximately 3 million red blood cells are being manufactured in your bone marrow. Your immune system is conducting constant surveillance, identifying and destroying aberrant cells and invading pathogens. Your kidneys are filtering 180 liters of blood plasma per day, reclaiming glucose and amino acids and minerals while excreting waste. Your liver is performing hundreds of distinct biochemical reactions simultaneously, metabolizing drugs, synthesizing proteins, maintaining blood glucose levels. Your heart is pumping 5 liters of blood per minute, distributing oxygen and nutrients to every tissue in your body. This activity is enormously energetically expensive. Your body at rest burns approximately 80 watts of power, roughly the same as a standard light bulb, just maintaining its basic functions. When you exercise, this can increase tenfold. All of this energy comes ultimately from the oxidation of food, the chemical reaction between organic molecules and oxygen, releasing the energy stored in chemical bonds and using it to drive the biochemical machinery of life. And all of this activity, every metabolic reaction, every protein synthesis, every ion pump, every muscle contraction, depends absolutely on a continuous supply of oxygen and glucose to every cell. The oxygen and glucose are delivered by the blood. The blood is pumped by the heart, and when the heart stops, when cardiac arrest occurs, the delivery system fails. Not immediately catastrophically, but in a precise cascade. When the heart stops, blood flow ceases within seconds. The oxygen and glucose in the blood that is already in the capillaries surrounding cells can sustain cellular metabolism for a brief period, but only briefly. Different tissues have different tolerances. The brain, the most metabolically demanding organ in the body, consuming roughly 20% of the body's total energy budget, despite constituting only 2% of its mass, is the most sensitive. Within approximately 4 to 6 seconds of cardiac arrest, the glucose and oxygen in the brain's capillaries are exhausted. The neurons begin to fail. Within 10 to 15 seconds, consciousness is lost, not gradually, not with a dimming of awareness, but abruptly, as the electrochemical activity that sustains conscious experience falls below the threshold required to maintain it. This is the clinical moment of unconsciousness. It is not death, not yet, but it is the moment at which the person, in the experiential sense, effectively ceases. Everything that follows happens to a body that is no longer having experiences. Within 2 to 4 minutes of cardiac arrest, without intervention, the neurons in the most vulnerable regions of the brain, the hippocampus and the cerebral cortex, begin to experience irreversible damage. Not because they are being destroyed by anything external, but because the absence of oxygen triggers a cascade of destructive internal processes. Without oxygen, cells cannot maintain the steep ion gradients across their membranes that are the physical basis of electrochemical signaling. The gradients collapse. Calcium ions flood into neurons through channels that are normally tightly regulated. High intracellular calcium activates destructive enzymes, proteases, phospholipases, endonucleases that begin digesting the cell's own structural proteins, membrane lipids, and DNA. This process is called excitotoxicity. It is the brain destroying itself in the absence of the chemical environment required to prevent self-destruction, and it is irreversible. Once the calcium influx has proceeded far enough, the neurons cannot be rescued even if oxygen is restored. The damage is permanent. The 4 to 6 minute window for effective CPR and resuscitation, the window within which intervention can prevent permanent brain damage, is determined by the timeline of excitotoxic injury. After 6 minutes of cardiac arrest without intervention, the probability of neurologically intact survival drops precipitously. After 10 minutes, it approaches 0. But the brain's death, and here is where the definitions matter, is not the same as the death of the body. The brain may be irreversibly damaged within minutes, but other tissues survive much longer. Skin cells can remain viable for up to 24 hours after cardiac arrest. Bone cells can remain viable for 72 hours. Corneas, the clear tissue at the front of the eye, can be successfully transplanted up to 12 hours after a donor's death. Heart valves can be harvested up to 24 hours post-mortem. So when exactly does death occur? When the heart stops? When the brain stops? When the last cell in the body dies? The honest answer is that death is not a moment, it is a process, a cascade of failing systems, each with its own timeline, each defined by the specific metabolic requirements and tolerances of that tissue. The transition from living organism to dead matter is not a sharp boundary, but a gradient, a frontier that moves through the body's tissues over hours and days after the initial catastrophic failure of the central systems. This is why organ transplantation is possible, because the body does not all die at once. The kidneys of a brain-dead individual, maintained on a ventilator, are still performing their filtration function. The liver is still metabolizing. The heart is still beating, driven by its own intrinsic pacemaker cells, even after the brain has permanently ceased. The body is simultaneously alive and dead in different tissues at different rates. And after the last cell has failed, after the metabolic processes of even the most resilient tissues have ceased, something else begins. Something that, from a thermodynamic perspective, is one of the most interesting and important processes in any ecosystem. Decomposition. The word sounds grim. The reality is extraordinary. When a cell dies, when its active maintenance systems fail, the membranes that separate the cell's interior from its surroundings and that separate different compartments within the cell begin to break down. Not because they are attacked by anything external, but because the active processes that maintain them, the ion pumps, the lipid transport systems, the cytoskeletal tension have ceased. The membranes are not destroyed. They simply stop being actively maintained and passive physics takes over. Within the cell, organelles that contain powerful degradative enzymes called lysosomes rupture. The lysosomes normally function as the cell's recycling centers, breaking down damaged proteins and organelles in controlled, localized reactions. When the lysosomal membranes fail, those enzymes are released into the cell cytoplasm. And now, uncontrolled, they begin digesting the cell from the inside. This is autolysis, self-digestion. Every cell in the body contains the machinery for its own destruction. During life, this machinery is tightly regulated, deployed only when and where needed. At death, the regulation fails, and the machinery runs uncontrolled. The body begins, in a precise biochemical sense, to eat itself. Simultaneously, the microorganisms that live in the human gut, the gut microbiome, a community of approximately 38 trillion bacteria, begin to proliferate without restraint. During life, the immune system and the physical barriers of the gut mucosa keep these bacteria confined to the intestinal lumen. At death, the immune surveillance fails, the physical barriers deteriorate, and the gut bacteria escape into the surrounding tissue. They begin the process of external decomposition, consuming the carbohydrates, proteins, and lipids of the body's tissues, producing gases, organic acids, and a cascade of biochemical breakdown products. This process, putrefaction, is the major driver of macroscopic decomposition. The gases produced by bacterial metabolism cause the body to bloat. The breakdown of cellular proteins releases sulfur-containing compounds with characteristic odors. The body gradually softens, liquefies in some tissues as the structural proteins are consumed. In all of this, every step of this process is thermodynamically driven. The organic molecules in your body represent stored chemical energy, energy captured from food, organized into complex structures by the biochemical machinery of life. At death, that energy is released as the complex structures are broken down into simpler molecules. The process is exactly the reverse of the process by which you built your body. Oxidation instead of reduction, entropy increasing instead of being held at bay, energy dispersing instead of being concentrated. You are, from a thermodynamic perspective, an extraordinarily improbable arrangement of matter that required 13.8 billion years of cosmic evolution and a continuous input of energy to assemble and maintain. And at death, without the continued energy input, the laws of thermodynamics dismantle you, not out of malice, not according to any plan, but simply because dismantling increases entropy, and entropy increases. This is not the end of the matter that was you. It is the beginning of its next journey. The mind, the hardest unsolved problem in all of science. Let me talk about the mind, because everything I've said so far about the body, as extraordinary as I find it, is the easy part. The body is made of matter, and matter obeys physics, and physics is something I understand reasonably well. But the mind is something different. The mind is where the hardest unsolved problem in science lives. And the question of what happens to the mind at death is not a question that has a clean, established answer. Let me be precise about what I mean by the mind. Not the brain. The brain is a physical organ made of neurons and synapses and neurotransmitters and glial cells. And what happens to the brain at death is as well understood as any other biological process. I mean consciousness, subjective experience. The fact that there is something it is like to be you, that you have an inner life, a first-person perspective, a stream of experience that is yours and that is different from the objective description of the neural processes that produce it. This is what philosophers call the hard problem of consciousness, a term introduced by David Chalmers in 1995 to distinguish this question from the easy problems, the questions about the neural correlates of specific cognitive functions like attention, memory, and perception, which are difficult but in principle tractable. The hard problem is why any neural process produces subjective experience at all. Why isn't it all just information processing in the dark with no one home? We do not have an answer to this question. I want to be very clear about this. It is not that we have a partial answer or a working hypothesis. We genuinely do not know why physical processes in the brain produce conscious experience. We do not know what the relationship is between the objective, third-person description of neural activity and the subjective, first-person fact of experience. We do not know whether consciousness requires biological neurons or whether any sufficiently complex information processing system produces it, or whether it is something completely different from information processing. These are not fringe questions asked by people on the margins of science. They are questions that are taken seriously by some of the most rigorous thinkers in neuroscience, physics, and philosophy. And the reason they remain unanswered is not that we haven't tried hard enough. It is that they are genuinely hard, harder in some ways than any question in physics, because they require us to explain not just what happens, but why. What happens produces experience. Now, in the absence of a theory of consciousness, what can physics say about what happens to the mind at death? What we know with confidence is the neural correlate side of the story. We know what the brain is doing when it is conscious, and we know what happens to that activity at death. And the picture that emerges from the neuroscience is both precise and deeply strange. Consciousness, as far as we can measure it, is associated with specific patterns of neural activity. Not just the firing of individual neurons, but the synchronized, coordinated activity of large populations of neurons across different brain regions. The brain in a conscious state shows high levels of activity in the prefrontal cortex, the thalamus, and the parietal cortex, with strong dynamic connections between these regions, rapid, complex, continuously changing patterns of communication. When consciousness is reduced in dreamless sleep, under general anesthesia, these patterns simplify dramatically. The thalamus, which acts as a relay station for sensory information and plays a crucial role in maintaining wakefulness, becomes less active. The communication between different cortical regions becomes simpler, more stereotyped, less dynamic. The complexity of the brain's activity, measurable as the informational entropy of its EEG signals, drops. And at death, as oxygen deprivation proceeds and neural activity fails, there is a sequence of events that recent research has made much clearer than it was even a decade ago. In 2013, a remarkable study by Jimo Borjigin and colleagues at the University of Michigan reported something extraordinary in the EEG recordings of dying rats. At the moment of cardiac arrest, there was an initial reduction in brain electrical activity, as expected. But then within the first 30 seconds after cardiac arrest, as the brain was losing oxygen, there was a paradoxical surge of neural activity. The EEG showed a brief but intense increase in coherent, high-frequency oscillations, oscillations in the gamma frequency band, 40 to 100 hertzes, which are associated in the waking brain with conscious perception and attention. The gamma activity in the dying brain was not just present, it was more intense than anything recorded in the waking, normally functioning brain. The coherence between different brain regions, the synchronization of activity across the cortex, was higher in the dying brain, briefly, than it had ever been measured in the living brain. This finding has been replicated and extended. In 2023, a study of 4 human patients who died of cardiac arrest while EEG recordings were ongoing showed similar surges of gamma activity at the moment of death in 2 of the 4 patients, specifically in the moments following the removal of life support. The surge was localized to specific brain regions: the temporoparietal junction, an area associated in the waking brain with dreaming, visual hallucinations, and the sense of a unified self. What does this mean? Nobody knows for certain. The interpretations range widely. One interpretation is that the surge of gamma activity represents the brain's last desperate attempt to maintain function in the face of oxygen deprivation, a kind of physiological death rattle at the neural level. Another interpretation, more speculative but not without basis, is that this intense, brief surge of neural activity is the neural correlate of whatever subjective experience accompanies the dying process. That the reports of near-death experiences, the tunnel of light, the sense of leaving the body, the panoramic life review might have their correlate in this final, intense burst of organized neural activity. Near-death experiences are genuinely interesting data. They have been reported across cultures, across historical periods, by people who had no prior knowledge of what other near-death experiencers reported. The phenomenology is surprisingly consistent. A sense of peace, separation from the body, moving through a dark tunnel toward a bright light, encountering deceased relatives or a presence of extraordinary love and acceptance, and then in the cases where resuscitation occurs, being returned to the body with great reluctance. The temptation to interpret these reports as evidence of something surviving death is understandable and I think wrong. Not because the experiences are not real, the people who report them are having genuine experiences, but because the experiences are exactly what you would predict if a brain undergoing severe oxygen deprivation were producing a final surge of intense, disorganized, hallucinatory activity. The features of near-death experiences map onto the features of experiences produced by ketamine, DMT, and other anesthetic and hallucinogenic agents that disrupt normal neural function. They map onto the experiences produced by G-force-induced loss of consciousness in fighter pilots. They are consistent with what we would expect of a brain that is misfiring spectacularly in its final moments. But here is the honest thing. This interpretation is consistent with the data. It is not proven by the data. The data, the reports of near-death experiences, are also consistent with interpretations that posit something surviving the death of the brain. Not any specific religious interpretation, but the general claim that consciousness, or some aspect of it, continues after the brain ceases to function. I am a physicist, I follow the evidence. And the evidence as I read it does not support the survival of consciousness after death. Not because I am certain that consciousness doesn't survive, I am not certain of that, but because there is no positive evidence that it does, And because every feature of consciousness that we can measure is closely tied to the physical state of the brain in ways that make it overwhelmingly probable that consciousness ceases when the brain ceases. But I hold this view with appropriate uncertainty, because the hard problem of consciousness is genuinely unsolved, because we do not have a theory that explains why brain activity produces subjective experience, and because without such a theory, we cannot be certain of what happens to experience when brain activity stops. What I can tell you with confidence is this: the neural correlates of consciousness, the measurable, objective features of brain activity associated with conscious states, disappear at death. The tightly organized, highly complex, dynamically coordinated patterns of neural activity that accompany waking consciousness collapse within minutes of cardiac arrest, replaced first by the desperate final surge and then by silence. Whether that silence is the end of experience or merely the end of the physical correlate of experience, whether there is anything it is like to be dead, is a question that physics, as currently constituted, cannot answer. I find this deeply interesting, and I find it important to say clearly, I don't know. That is the honest position. The energy, nothing is lost. Everything is transformed. Now let me tell you about the energy, because this is the part that I find most astonishing and most misunderstood, and in some ways most important. People ask, where does the energy go when you die? And the answer that most people give or assume is that it dissipates, that it spreads out, that the organized, purposeful energy of a living body disperses into the random thermal noise of the environment, becoming useless, becoming nothing of consequence. This answer is not wrong, exactly, but it is profoundly incomplete. And the complete picture is one of the most beautiful things in all of physics. Let me start with a precise accounting of the energy in your body. Your body contains energy in several forms. There is chemical energy, the energy stored in the bonds of organic molecules, the ATP in your muscles, the glycogen in your liver, the fat in your adipose tissue, the proteins in your cells. There is thermal energy, the kinetic energy of your molecules, which manifests as your body temperature of 37 degrees Celsius. There is electrical energy, the ion gradients across cell membranes, maintained by active ion pumps, which are the physical basis of all electrochemical signaling in your nervous system and heart. And there is, in the deepest and most precise sense, mass energy, the energy locked in the rest mass of every atom in your body, expressed by Einstein's famous equation, E equals mc squared. This is the energy that would be released if your atoms were annihilated, if every proton and neutron and electron in your body were converted directly to photons. The rest mass energy of a 70 kilogram person is approximately 6.3 times 10 to the 18 joules, about 1.5 billion tons of TNT equivalent. This energy is locked in your atoms in a form that is never released under any ordinary biological or chemical process. It is the energy of matter itself. None of this energy disappears at death. This is not a statement of faith or hope. It is a statement of law, the first law of thermodynamics, the conservation of energy. Energy cannot be created or destroyed. It can only be converted from one form to another, or transferred from one system to another. Every joule of energy in your body at the moment of death is accounted for in the universe after your death, not approximately accounted for, exactly accounted for. So what specifically happens to each form of energy? The chemical energy is the most active at the time of death and in the period immediately following. During the decomposition process I described in the first part, the autolysis and putrefaction, the complex organic molecules of the body are broken down by enzymatic and bacterial processes. The energy stored in the chemical bonds of proteins, carbohydrates, and fats is released in a series of oxidation reactions. Some of this energy goes into the growth and reproduction of the microorganisms driving decomposition. Most of it is released as heat thermal energy that disperses into the surrounding environment, warming the air and soil by an infinitesimal amount. The thermal energy your body heat disperses immediately after death through the same mechanisms of heat transfer that operate during life. Conduction into any surface your body is in contact with, convection through the air surrounding you, and radiation as infrared electromagnetic radiation. The rate of cooling follows Newton's law of cooling. The body's temperature approaches the ambient temperature exponentially, losing heat faster when the temperature difference is large and slower as it approaches equilibrium. This process, algor mortis, the death chill, is well known to forensic scientists and proceeds at approximately 1 to 1.5 degrees Celsius per hour under typical conditions. The electrical energy, the ion gradients across cell membranes, dissipates within seconds to minutes of cellular death as the membrane integrity fails and the gradients collapse. The electrochemical potential energy that maintained these gradients is converted to heat as ions flow down their concentration gradients through whatever channels remain functional. And the mass energy, the rest mass of your atoms, is conserved perfectly. Your atoms are not destroyed at death. They are not even damaged in most cases. The atoms that constitute your body, the carbon, hydrogen, oxygen, nitrogen, calcium, phosphorus, and trace elements, are exactly the same atoms after decomposition as before. They are now in different chemical compounds, organized into different molecules, distributed into different organisms and environments, but they are there, every single one. This is the extraordinary thing that I want you to understand. The atoms in your body are not yours. They never were. They were borrowed for the duration of your life from the common pool of atoms that cycles through the biosphere. You are assembled from atoms that were before you in plants and animals and soil and water and air. The carbon in your muscles was, a few years ago, carbon dioxide in the atmosphere. The iron in your blood was millions of years ago, iron in a dead star. The water in your cells has been cycling through the oceans and the atmosphere for billions of years. And after your death, those atoms will continue their journey. The carbon will be released as carbon dioxide by the decomposers and will re-enter the atmosphere, where it will be fixed by photosynthesis into new organic molecules in new plants. The nitrogen will cycle through the nitrogen cycle from organic molecules to ammonia, to nitrates, to atmospheric nitrogen, and back over timescales of years to centuries. The heavier elements will eventually, on geological timescales, be incorporated into rock, subducted into the Earth's mantle, and eventually released in volcanic activity. Your atoms will be in stars again, if the universe lasts long enough. This is not a metaphor. The sun loses mass continuously through the solar wind and through the radiation it emits. The Earth will eventually be consumed as the sun expands into a red giant, and the atoms that were once in your body, along with the atoms of everyone who ever lived, and everything that was ever alive, will be incorporated into the expanding envelope of the dying star, dispersed into the interstellar medium, available to be incorporated into new stars and new solar systems. The atoms are eternal, at least they are eternal on any timescale relevant to human imagination. Individual protons may eventually decay after times on the order of 10 to the 34 years or longer, and even if they don't, the sun's expansion and the eventual fate of the Earth will disperse them. But on the timescale of billions of years, your atoms simply move through the universe, changing their configurations, their chemical combinations, their locations, but remaining conserved permanent. This is the first law of thermodynamics applied to a human life. Nothing is lost. Everything is transformed. Now I want to push this further, because there is a form of energy that I have not yet discussed, one that is perhaps the most important and the most frequently overlooked, and that is information. The atoms in your body are not all the same. Carbon is carbon, and hydrogen is hydrogen, whether they came from a human being or a rock. What makes a human being different from a rock, from any random arrangement of atoms, is not the atoms themselves, but their arrangement. The specific configuration, the sequence of bases in your DNA, which encodes the instructions for building every protein in your body, the specific pattern of synaptic connections in your brain, which encodes your memories, your learned behaviors, your personality, your particular way of being in the world. This information, this specific arrangement of matter, is what makes you you, rather than some other arrangement of the same atoms. And at death, this information is destroyed. Not the atoms, the arrangement, the pattern, the specific configuration that distinguishes this particular 70 kilogram arrangement of matter from any other possible arrangement of the same atoms. Within hours of death, the DNA in your cells begins to fragment as the nucleases released by autolysis cut it into smaller and smaller pieces. Within days, the specific protein structures that encode the architecture of your brain, the synaptic weights, the dendritic morphologies, the specific connectivity patterns that constitute your memories are disrupted by the enzymatic and bacterial decomposition of neural tissue. Within months to years, depending on burial conditions, the molecular information that defines you as a biological individual is completely erased. And here is the deepest and most important sense in which death is real and irreversible. The information is not conserved. The atoms are conserved. The energy is conserved. But the specific, improbable, extraordinarily complex arrangement of matter that constituted you, that arrangement is gone, and it will never exist again. The universe will never spontaneously reassemble the specific arrangement of atoms that is you. The probability is not zero, it is an extraordinarily small but finite number. But in the expected lifetime of the universe, it effectively never happens. You are a pattern. The pattern is temporary. The matter is permanent. And when the pattern ends, what remains is the matter changed, redistributed, cycling through the universe on its next journey, but no longer you. This is not tragedy. It is not consolation either. It is simply the truth. What it all means, the most astonishing thing physics has ever said about death. I want to talk about what all of this means, not in a sentimental way. I am not a sentimental person by nature, and I don't think sentiment serves us well when we are trying to understand things clearly. But the physics of death has implications that I think are worth sitting with carefully, because they change the way you see what is happening right now. Let me start with the question of uniqueness. The arrangement of atoms that constitutes you, the specific sequence of your DNA, the specific wiring of your brain, the specific pattern of all your experiences encoded in your neural connectivity, this arrangement is, with probability indistinguishable from certainty, unique in the history of the universe. Not just rare, unique. The number of possible ways to arrange the approximately 7 times 10 to the 27th atoms in a human body, the number of possible sequences of those atoms is so enormous that the probability of any specific arrangement occurring twice, even over the entire history of the universe, with its 10 to the 80th atoms and its 13.8 billion year duration, is negligibly small. You have happened once. You will not happen again. And this is not a statement about your value. Value is a human concept that physics does not speak to. It is a statement about your physical specificity. The particular pattern of information that constitutes you, that has never existed before and will never exist again, is currently experiencing the universe through the interface of your body, your senses, your nervous system, right now, for a finite and unknown duration. This is what is actually happening. The universe assembled from atoms that have existed for 13.8 billion years, a specific configuration of matter that is capable of experiencing, thinking, wondering, loving, and being curious. And that configuration you is in the process of using its time. The atoms will continue after you. The energy will continue after you. What will not continue, what cannot continue, because it is uniquely dependent on this specific arrangement, is the perspective, the first-person experience, the particular view from here. And now let me tell you something about the time scale, because I think it is important to have a precise sense of where we are in the story. The universe is 13.8 billion years old. The Earth is 4.5 billion years old. The first single-celled organisms appeared on Earth roughly 3.8 billion years ago. The first multicellular organisms appeared roughly 600 million years ago. The first vertebrates roughly 500 million years ago. The first mammals roughly 225 million years ago. The first hominins, the lineage that includes modern humans, roughly 6 million years ago. Modern Homo sapiens, our species, roughly 300,000 years ago. You are, in other words, an extraordinarily recent product of an extraordinarily long process. The evolution of complexity from simple chemistry to single cells to multicellular organisms to animals to mammals to primates to humans took nearly 4 billion years, and the product of that process is a brain capable of asking why any of this is happening. There is nothing in the laws of physics that required this outcome. Nothing in the equations of quantum mechanics or general relativity or thermodynamics that demanded the emergence of complex life, of nervous systems, of consciousness. The universe is not obligated to produce creatures that wonder about it, and yet it has, or at least it has here on this planet, around this star. The arrangement of atoms that is currently reading this sentence or listening to my voice is one of those creatures. And the fact that this arrangement will eventually be dismantled, its atoms returned to the common pool, its information erased, its perspective extinguished, this fact, does not change what is happening right now, which is that the universe is experiencing itself through you. Now let me talk about something concrete, because everything I've said so far is true and important, but also abstract. Let me bring it down to the molecular level, because I think seeing the detail makes it more vivid, not less. At the moment of death, at the moment cardiac output ceases and the supply of oxygen to the brain stops, you are approximately 65% oxygen, 18% carbon, 10% hydrogen, 3% nitrogen, 1.5% calcium, 1% phosphorus, and a collection of trace elements. These percentages are by mass. By atom count, hydrogen is by far the dominant element. Your body contains approximately 4.2 times 10 to the 27th hydrogen atoms. Every single one of those atoms will, after your death, continue on its journey through the universe. The hydrogen atoms, the most common atoms in your body, are among the oldest atoms in existence. Hydrogen was synthesized in the first 3 minutes after the Big Bang, in the era of Big Bang nucleosynthesis. The hydrogen in your body has been in the universe for 13.8 billion years. It has spent much of that time as part of water molecules in the oceans, in clouds, in the bodies of other organisms. It will continue to cycle through water, through organisms, through the biosphere and hydrosphere, for as long as the Earth exists. The carbon in your body, the second most common element by mass, was synthesized in the cores of stars that lived and died before the sun was born. The triple alpha process that fuses helium into carbon requires the carbon 1,2 nucleus to have an excited energy state at just the right energy, a coincidence that Fred Hoyle famously predicted from the mere fact that carbon-based life exists. Every carbon atom in your body is the product of nuclear physics in a stellar interior, ejected into space in a supernova or stellar wind, incorporated into the molecular cloud that collapsed to form the solar system, processed through geological and biological cycles on Earth, and finally assembled into the organic molecules of your body. When you decompose, that carbon is released as carbon dioxide, as methane, as the carbon backbone of organic molecules consumed by decomposers. Some of it will become part of new organisms within months. Some of it will cycle through the atmosphere for decades. Some of it will eventually be incorporated into sedimentary rock, where it may remain for hundreds of millions of years before being released again in metamorphic or volcanic processes. On time scales of billions of years, the carbon in your body will be in the envelope of the expanding sun. It will be dispersed into the interstellar medium. It will be incorporated into new solar systems forming around new stars. It will cycle through whatever forms of chemistry and potentially whatever forms of life exist in those systems. Your carbon will be elsewhere in the galaxy, long before the galaxy itself is disrupted. Your hydrogen will cycle through the universe for as long as stars are burning. The information that organized these atoms into you will be gone in decades. The atoms themselves are essentially eternal. Let me say something now about what this means for how we should relate to death. Not in a religious sense, again, that is not my domain. In a physical sense, the fear of death, as I understand it, has two primary components. The fear of the process of dying to pain, and the loss of function, and the awareness of what is happening. And the fear of non-existence, the idea of not being there, of the world continuing without you, of being gone. The physics of death addresses the second fear more directly than the first. And what it says, precisely and unsentimentally, is this: you are not going anywhere. Your atoms are going on an extraordinarily long journey that was already underway long before you were assembled. You have been, for the duration of your life, a temporary organization of matter that was borrowed from the universe and is being returned. The return is not a tragedy, it is the completion of a transaction that began 13.8 billion years ago. The pattern, the specific arrangement that is, you will end. This is real. This is the irreversible aspect of death that no physics can soften. The specific view from here, the particular first-person perspective constituted by this arrangement of neurons and synapses and memories, will cease. But the universe out of which you were assembled will continue, and it will, in its blind, impersonal, thermodynamic way, continue to assemble complex structures, not you, never you again, but structures of comparable or greater complexity. Life on Earth will continue to evolve, producing organisms of kinds we cannot predict. The universe will continue to expand, producing structures on scales we cannot imagine. You are participating in this process right now, not as a passive observer, but as an active part of it, as one of the extraordinarily improbable configurations of matter that the universe has produced temporarily and through which the universe experiences itself. This is what is actually happening. This is the physics of your life and your death, stated as precisely as I know how to state it. I have been asked Many times, whether knowing the physics of death makes it less frightening, whether understanding the conservation of energy, the cycling of atoms, the thermodynamics of decomposition makes the prospect of dying easier to face. My honest answer is, not exactly. Knowing the physics does not change the personal reality of loss, of the ending of experience, of the specific and irreplaceable perspective that will cease. These are real. The physics does not make them unreal. But knowing the physics does, I think, change the scale at which you understand what is happening. It places your life in a context that is both more specific and more vast than any religious or cultural narrative I know of. More specific because it identifies exactly what you are, this particular arrangement of 7 times 10 to the 27th atoms, organized by billions of years of cosmic and biological evolution into a configuration capable of wondering about its own origins and fate. More vast because it traces that arrangement back to the nucleosynthesis of the first minutes of the universe and forward to the dispersal of your atoms into the interstellar medium billions of years from now. You are, in the most precise physical sense, a temporary organization of very old matter. The matter has been here for almost 14 billion years. The organization you has been here for decades. And the matter will be here in various configurations for billions of years to come. Nothing about this is ordinary. Every atom in your body carries the history of the universe in its structure. Every electron in your neurons is entangled with the history of quantum mechanics from the first moments of time. Every breath you take is a participation in the cycling of matter that has been going on since long before the Earth existed. I have spent my life being astonished by the physical world, by the strangeness of quantum mechanics, the beauty of electrodynamics, the unexpected richness of simple equations. And nothing I have encountered has astonished me more than the realization of what it means to be made of matter, to be temporarily a particular and irreplaceable organization of atoms that have been moving through the universe since long before life existed and will continue to move long after it has gone. You are not a soul temporarily inhabiting a body. You are not a consciousness that uses a brain. You are this arrangement of matter, this specific, improbable, extraordinarily complex pattern for as long as the pattern holds. And when the pattern ends, the matter continues, changed, redistributed, cycling forward through whatever comes next. That is the physics of what happens to your body, your mind, and your energy the second you die. Not comfort, not condemnation, just the extraordinary, precise, beautiful truth. The atoms carry on, the pattern ends, and the universe, indifferent and magnificent, continues.